So what is Pascal's law? The Pascal's law states that the external static pressure applied on a confined liquid is distributed or transmitted evenly throughout the liquid in all directions. So that is, any change in pressure felt in any part of a confined incompressible fluid will be felt in all other parts. So take the case of a toothpaste. The toothpaste, when you press here, there's a change in pressure. So this same change in pressure is also felt here, which causes the paste to come out. So that is called Pascal's law. So in other words, you can say that the pressure acting on a fluid is equal in all directions. So let us go to the proof here. So for proving Pascal's law, so we are taking a wedge-shaped fluid element. That means if you take a fluid here, so we will take a wedge-shaped fluid element which is of infinitesimally small dimensions. So, so the dimensions are delta x, delta y, and delta z. And the depth of this fluid element is 1, taken as unity. That means the depth, if you take the direction perpendicular to this paper, so in that direction its length is 1. So what all are the various forces acting on this fluid element? So if you take in the y direction, you can see that there is a pressure P2, and in the x direction you have a pressure P1, and this direction you have a pressure P3, that is perpendicular to the plane. So if you take the x direction, so what all are the forces acting in this direction? And similarly, if you are taking the y direction, what all are the forces acting on this direction? Since the fluid element is stable, that is in equilibrium, that means all the forces are balanced. So all the forces in the x direction and y direction are balanced. So let us write the forces in the x direction. So x direction, the forces acting is equal to the pressure here into the surface area here. So the surface area here is delta y into 1, that is the length, vertical length, into the depth, that is unity. So that is equal to P1 into delta y into 1. And for what is the force in this direction? F is equal to P3 into delta Z into 1. 1 means the depth, that is unity, we have taken it as unity, into 1. And if you resolve this force, so this force is in this direction, if you resolve this force, so this is Fx and this is Fy. So Fx will be equal to P3 into delta Z into 1 into sine theta. And Fy will be equal to P3 into delta Z into 1 into cos theta. So, and sine theta is equal to delta y by delta Z, that is trigonometry. So we can write P1 into delta y is equal to P3 into delta Z into delta y by delta Z. So that means delta Z will be cancelled off, and here delta y will be cancelled off. That means P1 is equal to P3. So here it is P3. Not P2, it is P3. P1 is equal to P3. Now we want to prove P2 is equal to P3. For that, we will take the y direction. So what all are the forces acting in the y direction? So if you write, you can see that there is a force acting here, that is P2 into delta x into 1. Just like the earlier case. So P2 is the pressure and delta x into 1 is the area. This will be equal to P3 into delta Z into 1 into cos theta. We have seen how the forces are resolved. We resolve the forces to find the Fy. Fy is equal to P3 into delta Z into 1 into cos theta. And you know cos theta is equal to delta x by delta Z. That is basic trigonometry. And if you substitute cos theta Here you will get this is P2, P2, and this is P3. This is P3. So P2 into delta X will be equal to P3 into delta Z into delta X by delta Z. So delta Z will be cancelled off and delta X will be cancelled off. That means you will get P2 is equal to P3. So that is how you prove, that is P1 is equal to P2 is equal to P3. That means pressure will be equal in all directions. So this is another application of Pascal's law. You can see that the pressure is transmitted equally in all directions. So when you apply a force here, a pressure is created here. That pressure will be transmitted at this point also. So any pressure change that is felt in any part of that confined incompressible fluid, that pressure will be felt somewhere else or in all other places. So whatever pressure that is applied here, you will get the same pressure here also. So this is a small video that is showing that. So you are applying a pressure, so that pressure is transmitted equally in all directions. So, so that means P is equal to F1 by A1. This will be equal to F2 by A2. So this is the principle used in hydraulic jackies. That means by applying a small force here, you can lift a heavy load here, because F2 will be equal to, F2 is equal to F1 into A2 by A1. Since A2 is greater than A1, very much greater than A1, you can get a very large force there. So that means you can lift a very heavy load.